This program is made possible by a grant from the Federal Emergency Management Agency, the Illinois Emergency Management Agency, and the Illinois Department of Commerce and Community Affairs. Distribution was underwritten in part by the Institute for Business and Home Safety.
We're all used to seeing these kinds of pictures from hurricanes, tornadoes, and other natural disasters. In the most severe storms, structures are obliterated. But in many less powerful wind events, light frame buildings often come apart bit by bit, or level by level. The lessons learned in Hurricane Andrew in 1992 prompted building officials in coastal areas of the country to increase code requirements for wind resistance, largely by requiring that light frame structures be connected together to better resist separations at structural joints. This program was produced to encourage the adoption of wind-resistant construction techniques in areas where they're not mandated, especially in parts of the country vulnerable to high-velocity straight-line winds and to supercell systems that produce tornadoes. These central Illinois buildings were damaged by tornadoes and high-velocity straight-line winds. As you can see, much of the damage occurred through separations at major structural joints, where the roof meets the walls, where the sidewalls meet the floor, and where the building is attached to the foundation. Putting the exterior of your home together creates what engineers call a continuous load path or a tension chain of resistance. And like a chain, this structure is only as strong as its weakest link. This two-story section of wall is typical of the construction techniques used in the homes you just saw. It's called platform framing and is a common building method used throughout the United States. Platform framing allows for efficient production in home building by allowing a kind of panelization of the structure. First, the floor system is constructed and attached to the foundation. Then the walls are assembled flat on the floor and stood up into place. Upper floors are constructed in the same way as our upper story walls. Finally, roof trusses or rafters are set in place and nailed down. These methods enhance speed in construction and, in the case of panelized buildings, allow for walls to be constructed in the shop, trucked to the site, and set in place with a crane. Unfortunately, these techniques rely mainly on gravity to hold the components in place. Take a look at the end of this wall and I'll show you what I mean. This floor assembly is sitting on the mud sill, a band of treated lumber which rests on the foundation. But this attachment is usually done with slant nailing or toe nailing. The floor deck is nailed down to the floor joists, and then the walls tilted up and nailed down into the floor. And remember, when these walls are constructed, the studs are connected at the bottom and top plates with nails which run vertically. The same techniques are used in multiple story homes. A second story floor is slant nailed to the wall assembly below it, and the process is repeated with the upper wall assembly. Finally, the roof trusses or rafters are set in place and typically secured with slant nailing. This is the traditional way that platform framing has been done for decades. But remember, these techniques rely almost exclusively on gravity and the weight or mass of the structure to hold it in place, and provides only minimal uplift resistance when modern construction materials are used. Structural engineers calculate something called withdrawal resistance for different kinds of nailing connections. For example, this connection, where 2x4s are nailed together forming the top plate in a wall assembly, provides only minimal uplift resistance. And this connection, where the bottom and top plates are attached to the wall studs, are rated at 0 for uplift resistance. Why is this important? High winds create three kinds of forces on a house. The first is an uplift force, where the roof acts like an airplane wing, and the wind passing over the top attempts to lift the structure straight up, taking off the roof, separating at the floor levels, or taking the entire house off its foundation. The second is a sliding force, which attempts to push the entire house off its foundation. And the third is an overturning force, where the structure attempts to pivot on the leeward wall. So, what can we do to prevent these kinds of separations from uplift forces? There is a very simple way of sheathing the outside of a house that uses common materials, requires minimal training, and on the face of it makes perfect sense. But it does require a departure from tradition. By starting the exterior sheathing at the very bottom of the wall at the mud sill and continuing up the wall, you can create a continuous membrane which causes the entire wall to act as a unit. Using this technique, the sheathing spans those vulnerable structural joints where separations often occur. Take a look here. We've crossed each of these joints with half-inch sheathing all the way to the top plate of the second-story wall. In doing so, we've created a dramatically stronger structure. Where joints occur in the sheathing, 2x4 blocking applied across the joints on the back side allows this entire wall to act as one unit. It's also important to continue this sheathing on any gable end of the house so that it spans those structural joints as well. Finally, the roof trusses or rafters can be attached to the side walls with metal connectors like this, and you've tied your entire house together. Okay, you're saying, this makes sense. What's the big deal? The big deal is that this is not the way it's traditionally done. Customarily, a 4x8 structural panel is installed in each corner. This is usually required by code, and an insulation board of the same thickness is used to fill in the balance of the wall. The areas left uncovered at the floor levels are usually filled in with insulation board or scrap material to provide an even surface for application of siding. The shortcomings of this kind of sheathing are not immediately obvious to the casual observer. Since the material typically used is 8 feet long, it won't span the joints at both ends of the wall studs, and these joints at floor level are left completely vulnerable to uplift forces. In other words, this kind of sheathing layout provides no uplift resistance. And remember, it's at these very joints where the failures occurred in the damaged homes we showed you earlier, where the walls meet the floors, where the roof is attached to the sidewalls, and where the entire structure meets the foundation. These methods are in widespread use throughout the country in homes that span the price range for single-family residences. Some builders may use structural panels to sheathe the entire exterior instead of using insulation board, but if you look closely, the application is the same, with 4x8 sheets covering wall assemblies and scrap pieces filling in the gaps at the floors, leaving these construction joints vulnerable to separation. Another weak link in the chain of resistance can be where the wooden structure is attached to the masonry foundation. This connection is vulnerable to all three forces generated by high winds: uplift, overturning, and sliding. In the case of hollow masonry units or concrete blocks as we see here, it's important to properly reinforce the wall by using steel rebar and then to grout the cores of the blocks by filling them with concrete. And it's critical to properly anchor the mud sill to the foundation. Instead of using small anchor rods with a light gauge washer and nut as we see here, we recommend using heavy-duty longer anchor bolts with large square washers to spread the uplift force across more of the mud sill. There are other ways to achieve continuous load path in your house without applying continuous sheathing. You can use a variety of metal connectors like these that span construction joints. These materials can also be used on an existing home during a remodel project or when residing. Whether during new construction or remodeling, perhaps the most cost-effective enhancement you can incorporate into your home is an upgraded garage door. Large, lightweight garage doors are often the first thing to fail in high winds, and wind entering a garage often leads to sidewall failure and roof failure. Fortunately, heavy-duty, wind-resistant garage doors are already available from most manufacturers because of mandates in coastal areas. These doors are often available for as little as $100 over the cost of an unrated door of the same style. The technology related to wind-resistant construction has advanced significantly since Hurricane Andrew, and there's a wide array of materials from numerous manufacturers to help you build wind resistance in your home. Today's home buyer is accustomed to having a wide range of options available in a new home, everything from the number of bedrooms and baths, the kinds and quality of finishes, to amenities like fireplaces, decks, and swimming pools. However, if you're interested in building a home with these wind-resistant features, you'll probably have to ask for it specifically, and be prepared to pay a little extra. Depending on the size of the home, the increased costs in material and labor may range from a few hundred to a few $1,000s. Now, we need to be clear about one thing. The building techniques we've demonstrated won't resist a direct hit from a tornado. The wind forces in a strong tornado are very devastating. They're the strongest winds on our planet. Luckily, strong tornadoes are an infrequent hazard. Straight-line winds, however, are a much more common occurrence, and their damage tends to be more widespread. It's for this type of hazard that we recommend you consider building your home with these techniques. It's been shown that homes built this way can survive strong winds with relatively minor damage. And to protect you and your family from the most severe storms, plans are now available for construction of a safe room inside your house. The devastation of the Oklahoma and Kansas tornadoes in the spring of 1999 served to reinforce the Federal Emergency Management Agency's recommendation for inclusion of these safe rooms in homes. In the Del City, Oklahoma storm, one of these small reinforced structures withstood the winds of an F5 tornado, winds in excess of 260 miles per hour. The knowledge that your home is well built can provide some peace of mind during severe weather. You'll be comforted by the fact that you took a positive step to reduce the risk that your home could be significantly damaged or destroyed, and many of the items that make your house a home may be better protected. Taking proper shelter with your family and also taking these steps during construction or remodeling of your home will be the best defenses available when you and your family face the storms that are certain to come. It just makes good sense to be prepared.